Hello guys, let's continue our quantitative trading course, and today we are going to talk about reinforced learning. In the previous lesson we developed several files, and the main files for us is dataset when we going data from Binance server. So let's create new files. And before we do it, I would like to say that reinforced learning um, include several parts like environment, action, training, models, and to full understand how it works, we need to divide this topic on several parts. So today we are going to develop environment files, and these files it means it would be some environment, financial environment for agent when we are going to train models to make decisions. So to do it, let's create files. We're using touch, would be environment file. Let's do it. Okay, we created it. First we need to import several libraries. It would be Python, it would be NumPy, import NumPy, and also we need to import a random library because we are going to take some random split from dataset, and also we need class dataset from file dataset when we download the data from Binance server. From dataset import dataset class. Okay, so next we need to create several class to develop environment. The first class would be actions. It means we need actions like buy, sell, or hold to make decision, and also we need to make some sample from dataset. Let's do it. Create class. The class actions, for example, would be def init, and we need number of action indicate. It would be self n would be n. Okay, next let's create sample, and we return random integer from 0 to minus 1. It means we return some random action when we are going to explore this data set. And our agent should sometimes make decision basic on neural network, and sometimes to make decision for random sample. It means we should sometimes explore new data, new relationship. It's very important to separate this one. And let's create another class like observation space. Would be def init where we should return shape. Okay, it would be shape for dataset. Okay, and the main class would be environment class. Environment would be, we also need init. Okay, and we need to take several arguments like symbol. For example, we are going to download Bitcoin USDT, and also we need feature. For example, for first version we're going to use only closed data, but when we would like to expand this environment, we could create a different feature using technical indicators or another. Okay, self symbol would be symbol. We create global variable, and we need to create observation space. Let's by default we take, for example, 5 last bars. It would be like look back. Okay, next one, self look back, self observation space, and you need to take shape from this space and first value from this shape, and we take 5 look back. Okay, looks good. What is okay? Next one, we need to create global variable like action space. Let's using two action. It would be sell or buy, but when we are going to create some complex agent, we need to create some complex environment, and it could be more action. For example, addition action could be hold. So let's use actions, and it would be only two action for agent. It would be sell or buy, and also we need create default variable like accuracy. Minimum of accuracy would be 48%, for example. Okay, next we need to get data from Binance. We do it before. Let's create private method like get data, and in this method we got data from dataset class. We call this dataset, and this class include method get data. And let's create 30 days, last 30 days. Ticker would be self symbol, what we import, and time series, let's do agent for 1 hour, for example. Okay, we downloaded this data. Next we need create self data, and we need take close data, and this variable would be different. For example, open or few feature like returns, RCI, volume, and another one. And to take, we need create some subset of data frame, and we take some data from this data frame. Okay, and let's do call this data here, and we download the data from Binance server and create data set for our agent. but we need to do some processing with this data set when we are going to create several variables, for example, or we need to take returns. Let's do it, and let's call method like create feature. It will be also self, and for example self data would be r, means returns, and let's do returns, and p, we take logarithm of returns. To see more dispersion, let's divide clause on previous clause, self data clause shift, we need to shift data on the previous. Okay, looks good. When we calculate these returns, we need to drop miss value. Let's do it, self data, and we need to call method drop now in place true. Okay, so we delete a missing value, because when we create returns we do a divide current value on previous value, and in this way we create some one miss value. Okay, so for reinforced learning algorithm, especially for neural network, very important to do some scalar. It's very important. Let's do it. It will be self data, and what we need to do, it self data minus we need minus mean, self data mean. This method of pandas data frame, and we need divided it on standard deviation. Let's do it, self data standard deviation. Okay, looks good. Also we need to create categorical variables, and we need to define direction of market. Let's do it, would be self data, let's call like direction, let's could be d, and we're using numpy, and I like this method, numpy where self data, where return would be more than 0, it would be 1, and another way it would be 0. Okay, so looks good. So we got data from Binance server, and we need to do some processing, and let's create a feature, and we need to call this method private method on initialization of class. Okay, looks good. Let's hide this one. Okay, so when we have some data, we need to get state on the current moment, and current state, it means what value exists on current moment. And when we working with only closed data, we need to take data close using look back. It means we take last 5 bars, for example. Let's do it. We also create a private method to the get state self, and we return self data, and we take feature, and our feature would be in this example close, but if you would like to change it, it could be another. Okay, and what else? Okay, we take a feature, and we need take look back, and we call ilog, and we could take bar and minus our look back, self look back by current bar, self bar, and we should return numpy an array, and to do it we call values. Okay, looks good. Let's do like this, it would be more beautiful. Okay, looks fine. And for enforced learning we need to reset our environment. Let's do it. We create method reset, and we are going to call this method when we learn, train our agent. Let's do it. It will be self and action. It would be reset. Let's do it. Okay, so we have some total reward when we train our agent, and we calculate a total reward, and we need to reset this value with the total reward would be 0, and also we need to reset accuracy. Oh, it would be accuracy also 0. Self bar would be self look back, because we're going to start from 5 bars, and our state would be we take data and we take feature from this data, and next we call method ilog. We do it before, and we take self bar minus self look back minus look back to our bar. It means we take a range. Look, okay. And what else? It would be our values, and let's okay, and we call values. And we need to return state. Let's check it from its name. I mean minus, we need minus this one. Okay. Okay, and we could return like this. Okay, looks good. After this we need to calculate reward, accuracy, and another useful feature for train our algorithm, and we need to create method step. Would be self, and for example we have some action. Let's do it. The correct equal action if self data direction on a specific index name, it means bar. Okay, and we need make reward. For example, reward would be 1 if it's correct, and another would be 0 reward. Okay, looks good. And to calculate total reward, we need plus of this reward. Looks good. And we need to shift our index of data frame. Let's also do shift self bar +1, and we calculate accuracy. Self accuracy would be self total reward and dividing on self bar minus self look back. Okay, next we need to do some processing. For example, if a self bar would be more than len self data, we return done. We return done would be true. We need to return this variable for reinforced learning. Done would be true. Elif reward would be 1, and we need done would be false. Okay, so it means we do training our agent step by step, and if this index of data frame would be more than len of our data frame, we should stop training. Okay, and we need to make condition for accuracy. For example, if self accuracy would be less than self minimum accuracy, and self bar would be more than self look back +10, and we also return done would be true. Okay, and another situation, we should return done would be false. So this is a condition to stop our agent reinforced learning of reinforced learning. So let's take statement self get state, and we need to return this one, and we also need to create additional variable would be empty dictionary, and we're going to use it in the next. And we need to return state, what is the current state, and what reward we got using this state, and conditional to stop our reinforced learning, and info. It will be required in the future. Okay, it looks good. Let's check correct action. Okay, reward, we calculate total reward, we shift step by step our data frame, we calculate accuracy, and If index of this data frame would be more than length of data frame, we stop this data. If reward would be 1, we continue to train, and also stop if we have this condition require on minimum of accuracy. Okay, and another one, we also to continue to train reward, train our agent. Okay, looks good. So let's check what is import. Strange. Let's delete it. Looks good, and we need to test it. Let's run, and for example, let's create environment. Would be class environment. For example, we would like to download Bitcoin USDT, and we take feature clause. I use list because we need to input this one into the data frame, and sometimes we need more than one feature. For example, like this value. But let's do it for only for one feature, for close data. Let's close. Okay, we close the data. Let's check how it's working. Reset. Let's for example call and reset. Let's look at what happens. Okay, when we call it, we reset data and return some state of the current moment of this bar. What is bar? Let's see. For example, env bar. Okay, 5 bar. We have 5 bar to look back. Okay, and let's create some action to test. Action would be env, and we need to call okay, action space with some sample. What does mean action space? We call this variable. What is this variable? It would be object of class, what we create when we initialize our class. And let's look in what is. And when we do a sample, we take random sample, and let's do it. What happens? Let's see what is action. For example, action 1, because we return integer between our number of action. In our case, we have only 2 action, but when we would like to create some smarter agent, could be action more than 2. For example, minimum 3 action. It means buy, hold, or sell. Okay, and if we have for this state some action, and we need check a reward, what it would be reward, and we need call action. Okay, action. I got an error. I need to fix it. I'm trying to find what happens wrong. Guys, I make bug and this one, and I need to fix it. Let's do it again. Let's create this environment again and reset. It's working. Action would be env action space sample. Action would be 0, for example, and let's do step on this action. Step function. Okay, so in this case we take this state and we got reward 1 and we return false. It means we continue to train. And let's, for example, action, we could change it for another action like this, or 0. Okay, so it's working. So we created environment for financial data, and let's create agent in the next video. See you next time, and thanks for watching this video.